Greetings to all who have tuned in to this session. This is the very first session in which we are providing some training to prospective Olympiad students run by the South African Mathematical Foundation. My name is Pillay, Pubalan Pillay, Professor Pillay, and I will be conducting this lesson today with you. This is the first of 8 sessions, and it is entitled Basic Algebra. So without much further ado, I will go on to the problems. We will try to do as many problems as possible, and in each case, we will try to give the background to that problem before proceeding to the solution. So, because we have a number of problems, I will be working rather briskly. So let's first go to the problem 1. And before we do problem 1, I need to recall for you the square, you can see where my pen is, of a sum. And the formula is a plus b, if you square it, it is a squared plus 2ab plus b squared. And this is not how it is normally written, but if you rewrite it, it is a squared plus b squared, at the first and the last, plus 2ab. Very often, people believe that a plus b all squared is a squared plus b squared. That is not true. You have to add one other term, and that is where you multiply the two numbers, ab, and double it to get this, and add that quantity to a squared plus b squared. In a similar way, a minus b all squared is you square each term, a squared plus b squared, and this time you subtract the double of the product. This is the double of the product. And usually it is written like this. And if you want to know why, you see a plus b all squared, what does it mean? It is a plus b multiplied by a plus b. Now, how do you expand this? You take a and you multiply it by a plus b, as we see here, plus b, right? Multiplied by a plus b. And when you, so this a into that plus b into that, and that is what you get. And when you expand this, a into a plus b is a times a, which is a squared, plus a times b, which is ab, plus ba plus b squared. And when you group together the like terms, ab plus ba is 2ab. And that is how you get this formula. All right, so that's the background to the very first problem. So let us now go and look at what that problem is. Okay, so the first problem is, what is 2023 squared minus 2 times 2000 times 2023 plus 2023 squared? Oh, sorry, it's supposed to be plus 2000 squared. All right, so let's just correct that. This is 2000 squared. Okay, so if you look at this, you got a square here. If you call this number here a, then what you got here is a squared. And if you call 2000, if you call it b, you got plus b squared at the end. And here you have minus 2, and you've got it. You got, this is b times a, which is the same as a times b. And we've just seen that this quantity is a squared minus 2ab plus b squared is a minus b all squared. And if you go back and substitute for a is 2023 and b is 2000. And here you could simply subtract these two. That's very easy. 2023 minus 2000 is 23 in brackets, 23 squared. And when you calculate that, you'll get 529. No calculators used, but you can just do simple long multiplication. Okay, so that takes us to the end of the first problem. The second problem reads as follows. If 1 minus 1 over m into 1 minus 1 over n equals 1, find m in terms of n. Right. So before we do that, let's just observe a few things. There are a couple of things I want you to notice, but let's start with this. You'll see in the bottom right-hand side, we are saying that a times b equals c. If you multiply two numbers and the answer is c, now the symbol here means implies. That means we can conclude. The conclusion is that each of the factors, a or b, in this case a, is c divided by b. And it's very important to know that if you multiply two numbers and you get something else, then each one is the product divided by the factor. And c divided b is the same as c over b. Right? That's very important. When you division is the same as taking a fraction. All right, so that's the first thing that I want to say. So if you got, for instance, if 2 times x equals x, what is x? Then, as we just saw, this is 2 multiply. This 2x means 2 times x. That means the answer is x is equal to 6 divided by 2, as we saw. It's the same as 6 over 2, or 6 divided by 2, and that is equal to 3. So in general, if you have a times x equals b, if we don't specify what the coefficient of x is and what the product is, then the same rule applies. We can say a multiplied by x equals b, and that implies that x is equal to a times x equals b. It means x is equal to b divided by a, which is that. Sometimes you might want to do it like this. Then you'll say, let's divide both sides by a. You got an equal sign. What you do to one side, you have to do to the other side. So divide both sides by a. So it's ax divided by a equals b divided by a. And then the a is cancelled because a times x divided by a, the a is cancelled. And you get x equals b over a, which is exactly the same as that. Okay, so if a times x equals b, then x is equal to b divided by b over a. Okay. Now, that brings us to what we call linear equations. Now, this is an example of a linear equation. A linear equation has got an unknown. The x is an unknown. Right? And it appears only as x, not as any other form, not x squared or anything like that, just as x. And in the equation, then you call it a linear equation. Now you take an example like this. Here you have an equation, there's an equal sign, and there is an x here, which is an unknown, and it doesn't appear as a square or anything like that. And so this is an example of a linear equation. Now there are two important rules in linear equation. The first rule is bring all the unknowns to one side. So wherever you have an x or a y or z, and you're trying to find that unknown, the single unknown. In a linear equation, there's only one unknown. Then you bring all the unknowns to one side, right? But when you cross the equal sign, change the sign when crossing the equal sign. So when you cross the equal sign, you're taking any object in that equation to the other side, you must change the sign. If there is a plus, you make it minus. So let's have a look at this. And you got this complicated thing. I'm going to go through this thing briskly. Minus 8 times x is minus 8x. Minus negative 8 times negative 7, it becomes plus 56. Here it's 4 times x is 4x. 4 times 1 is 4. Minus 7 times x is minus 7x. Negative 7 times negative 3, be careful, is positive 21. All right, so now you got rid of the brackets. So one of the first things you do is to get rid of the brackets, if there are brackets. And now you can bring this rule into play, bring all the unknowns to one side. So wherever you see x's, you bring it to one side. So you get negative 8x, you do this. But there's a 4x on this side, you're crossing the equal sign, so the sign changes. Plus 4x becomes negative 4x. There's a negative 7x here, crosses the equal sign, and it becomes plus 7x. So you got rid of the negative 8x, the negative 4x, all the x's. The only thing, then you leave the numbers on the other side. The 4 remains like that, so you don't do anything to it. Plus 21, it remains as this. But the plus 56 on the other side goes to this side, and the sign changes, it becomes minus 56. And then you simplify this, you get negative 5x. Simplify this, you get negative 31. And here you have negative 5 multiplied by x gives you negative 31. Therefore, x is equal to negative 31 divided by negative 5. And that's how we write this thing down. This is your C over B thing. And when you simplify this, you get 6,2. So these are the prerequisites that are needed to solve the next problem. And all these, whatever I told you now, is very important because they come up over and over again. So I took time to say it. Now, if you take this one here, this is a somewhat complicated example. But what have you got? They say, find m in terms of n. So what does that mean? Say find m in terms of n means that m is your unknown. So there's your unknown here, m, right? Now our rule is bring all the unknowns to one side. So this is not any linear equation, but the same rule applies. You got this times this equals 1, and you want to find m, so that's your unknown. So you isolate that, but this times this equals n, so therefore equals 1. So therefore 1 minus 1 over m is equal to 1 divided by the other factor. These two are factors. You multiply them, you get 1. So therefore this factor, this whole object, is equal to 1 divided by the other factor. Right? Now, at this stage here, I just want to say some other things. When you got a fraction, a over b, you can multiply a by anything you like, but you must multiply the b by the same quantity, right? So if you got ax over bx, you know you can cancel this and you get a over b. So you can multiply a by anything, but you must multiply the denominator by the same thing, right? So that's one important fact. In an equation, sometimes you have fractions, like this one here, this equation, you got fractions. And the way to deal with equations which have got fractions, I don't know about you, but I don't like to work with fractions. So the way to destroy the fractions or to get rid of the fractions is to look at the denominators, 2 and 7, and you look at a common multiple of the denominators. So 2 and 7, right? A common multiple is 2 times 7. So you can multiply, so that is 14, and you multiply both sides by that common multiple. Right? Sometimes you might want to multiply by the lowest common multiple, but it doesn't really matter. You can multiply by any common multiple. Like here, it's 14, which also happens to be the lowest common multiple. So multiply both sides. Multiply this by 14 equals, and you must multiply this by 14 as well. Now, 14 times half is 6 times half is the same as 6 divided by 2, right? Which is 3. So 14 times half is the same as 14 divided by 2. That is 7x. And here you got 14y over 7. 14 divided by 7 is 2y. And 14 times 6 is 84. And then you continue. Now you got an equation which has got no fractions in it. So this is a way to get rid of fractions. Okay. All right. So bearing that in mind, we can go back to the problem at hand, which is this one. So we had we had 1 minus 1 over m equals 1 over 1 minus 1 over n. I don't like fractions. So to get rid of these fractions, you want to multiply this entire thing by n, right? The common denominator, right? Which is n. But you must multiply both the top and the bottom. N times 1 is n. Multiply this whole thing by n. N times 1 is n minus n times 1 over n is just 1. The n over n is 1. Right. So there it is. You still haven't got your m, but you have simplified this. So let's bring the m to one side. So you get minus 1 over m is equal to n over n minus 1 minus 1, because this 1 here comes to the other side. And then you can simplify this, because this is a difference of two fractions. So 1 is 1 over 1. So you take the common multiple here. And if you simplify this, you get n minus 1 into n minus 1. N minus 1 goes into this 1 time. 1 times n is n. 1 goes into this n minus 1. Numerator times n minus 1. And if you simplify that, remove the brackets, and you get n minus 1 times n minus 1, minus 1 times n, minus 1 times minus 1 is plus 1. And again, you get rid of the like terms. N minus n is 0. So you got that. So therefore, you got negative 1 over m is equal to this. So how do you get m? Well, all you have to do is to turn it upside down. Okay, maybe we can change the signs first. So you get plus 1 over m is equal to minus 1 over n minus 1. And you change the sign, or you multiply on both sides by negative. The negative 1 times negative 1 is just plus, and you multiply this by negative. And now you can just turn this thing upside down. 1 over m is equal to n minus 1 over minus 1, which is minus of n minus 1. And the minus, you can put it at the top. And if you like, this is minus n plus 1. So that's the solution to find m in terms of n. Okay. There are other ways of doing it. You can expand this and try to do it, and you probably will get the same answer, but we don't have time for that. You can try to expand this whole thing, get rid of the fractions, and try to solve n in terms of m, or m in terms of n. Okay, so let's just get on to the next problem. Okay, problem number 3. Mary has 3 types of toys: teddy bears, cars, and jets. Right. So all her toys except 21 are jets. So if you count all the, what does this mean? If I had 50 toys, it means all toys are jets except 21. So 21 of those 50 toys are not jets, right? That's what it means. The same thing here, all her toys except 23 are teddy bears. So 23 of all her toys are not teddy bears. And the same thing with 26 of her toys are not cars. How many jets does she have? So we don't know how many jets or teddy bears or cars she has. So let's give symbols to each one of these. Okay, so we don't, these are unknowns. So this is a problem. And you got 3 unknowns because you don't know how many jets there are. So let's give names to this. Let x equal to the number of jets. Now the symbol for number is number of jets. And likewise, you got teddy bears. So let's give a name to the number of teddy bears. And likewise, give a name to the number of cars. All right. So all toys except 21 are jets. So what does this mean? That means if you remove the jets from that, you will get 21 toys. Right? So if you remove the jets from all these, it means y plus z, right? The remaining toys, there are 21 in number. So that is how we read this first sentence. All her toys except 21 are jets. So the remaining, the toys that remain when you remove the jets out, there are 21 of them. And in like manner, if you remove the teddy bears, which is y, from the whole lot, you'll have x plus z equal 23. And likewise, if you remove the cars, right, which is the z, you'll get x plus y equals 26. Okay, so now you've got the equation, but there are 3 unknowns, and the question is, how many jets does she have? So the question is, what is x? Now, this can be quite a, you might say, why are we giving a problem like this? You got 3 unknowns. Normally, you only have 1 unknown at this level, but this is a more advanced type of an equation, and you can solve it without knowing too much by just making an observation, right? You'll notice on the left-hand side, I've got 3 equations, and there are 2 x's, xx, 2 y's, and 2 z's. There are 6 numbers here. There are 2 x's, 2 y's, and 2 z's. So why don't I add everything up here, and I will get 2x plus 2y plus 2z. So add the 3 equations, and you add the 3 numbers on this side, right? And when you add them, you'll get 70. So 2x plus 2y plus 2z, that if you take 2 out, this is the same as 2 into x plus y plus z. When you expand this, you get that. Then you get x plus y plus z is equal to 2 times that is 70. So therefore, x plus y plus z, that is 70 divided by 2, as we saw earlier on, and that is 35. Right? So you wanted x, so you needed x. But x added to this quantity, now this one, we know what it is. There it is, y plus z. So that's 21. So this number here is 21. So what we are saying here is x plus, let me just go to the other side. So we have here x plus y plus z is 21. So I can replace that. And now you got only one equation and one unknown. See? So you can actually bring it down to that. And to solve, you bring the x's to one side and take all the others to the other side. And 35 minus 21 is 14. And that is the solution to problem 3. So let's get on to problem number 4. Problem number 4 reads as follows. The sums of 3 out of 4 numbers, omitting each of the 4 numbers in turn, are, the numbers are given, 20, 22, 24, 37. Each represents the sum of 3 numbers. 3 numbers out of 4, 3 numbers out of 4, 3 numbers out of 4, 3 numbers out of 4. When you add those 3 numbers, you're going to get these answers. Right? But there are 4 numbers. And the question is, what is the sum of the 4 numbers? Well, a tricky problem. But again, like the last example, we give symbols to those 4 numbers. See, we must not be afraid of giving symbols to unknowns, because then algebra steps in and it makes life very easy. See? So what we have to say is, we don't know what the 4 numbers are. Let's give names to them. Let A, B, C, and D be the 4 numbers. Right. Now, bearing that in mind, they say the sum of 3 out of those 4. In other words, if I pull out A, then the sum of these 3 numbers is equal to one of these. We don't know which one. And then if you pull out B, you'll have A plus C plus D. The sum of those 3 numbers is again equal to one of those. And then if you remove C, you'll have A plus B plus D. And then finally, if you remove D, you'll have A plus B plus C. Now, these are equal to these 4 numbers. Doesn't really matter. We'll just put them as 20, 22, 24, and 27. All right. Now we have something which is quite similar to what we had before. But there we had 3 equations for 3 unknowns. And here you got 4 equations and 4 unknowns. And that what we saw there earlier, can be used again here, because you'll see you got 12 symbols on the left-hand side, 3, 3, 3, 3. And you've got 3 B's, B, 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 3 C's, 3 A's, and 3 D's. And the question is, what is the sum of the 4 numbers? Let's just remember what the goal of the problem is. The goal is to find out what is A plus B plus C plus D. What is that equal to? Right? That is the sum of the 4 numbers. Now, if you look at these, and as we did before, we've got 3 A's, 3 B's, 3 C's, and 3 D's. Let's add everything, and you'll have if you add everything inside, add both sides. You're gonna have 3a's on the side, plus 3b, plus 3c, plus 3d. See, it's a useful trick. It doesn't always happen like that. Only in certain cases, special cases, you have the same number of unknowns as we saw in the previous case as well, you know, on both sides. And in that case, you can add both sides, because then you can remove that unknown. So when you add these four numbers, what do you get? You get 42, 66, 93. Right? So 3 into 3, you can take out 3 as a common factor. 3 into a plus b plus c plus d equals 93. See, because you can take out, if you expand this, you're going to get the same thing as that, 3a plus 3b. So you can remove it as a factor. And there you have it. Because we got a plus b plus c plus d. There's a plus b plus c is equal to 93 divided by 3. And 3 goes into this. 3 goes into 9 3 times. 3 goes into 1. So the answer is 31. The answer to this problem, sum of the 4 numbers, is what they asked us for. And the answer is 31. So let's get on to problem number 5. Problem number 5 reads as follows. There are 100 sweets in 5 bags. In the first and second, there are altogether 42 sweets. In the second and the third, there are altogether 43 sweets. In the third and the fourth, there are 34 sweets. And in the fourth and the fifth, there are 30 sweets. So there's a lot of information that is given here. So the question that is asked is, how many sweets are there in the first bag? Right, so we need to calculate the number of sweets in the first bag. And you might be tempted, as I did before, to say, well, there are 5 bags, and let's say the symbols, we say the 5 symbols for the number of sweets in each of the bags. All right? And then you'll give symbols like A, B, C, D, E, and you'll get equations. And you might be tempted to do it the same way as we did the others. But unfortunately, it doesn't work. Right? That method doesn't work. So we have to think of some other way. So let's just take the first information, and we're not going to use symbols, but we're going to say first bag. We'll call it the 100 sweets in all 5 bags. So the first bag plus the second bag, we wouldn't use symbols. We'll call it first, second, third, because this is what they are saying. First, second, third, fourth, and the fifth. If you add all the sweets in all the 5 bags, you're going to get 100. Now, the question is, how many sweets are there in the first bag? So in other words, this now becomes an unknown. That becomes an unknown. So we ask ourselves now, how can we do this? But it's very simple once you see it like this, because a little bit of thought will tell you that, a little bit of thought will tell you that all you have to do is the second and the third, we already know. The second and the third bags together, there are 43 here. And we also know the fourth and the fifth. The fourth and the fifth bags, there are 30. So it's very easy, because these two together is 43. These together gives you 30. So the 4 bags, second, third, fourth, and fifth, are 73 there. So therefore, the first bag has 100 minus, if you take it to the other side, minus 43 minus 30, as we saw, it's 100 minus 73, which is 27. So that's the answer to this problem. In one line, you can solve this problem. See, so sometimes you have to think carefully and don't get trapped into a certain mode of solution. Think about the problem and see whether there is a quick way of solving it. Okay, and this is an example of that. Problem number 6 reads like this. If x plus y equals a, y plus z equals b, z plus x equals c, determine x in terms of a, b, and c. This is very similar to the earlier problem we did. X plus y, first plus second, second plus third, third plus first, right? And when you write them down like this, which I have done, now this time you don't have numbers, you have symbols, but exactly the same process that we use there, we can use it here to solve this problem. The problem is to find x in terms. In other words, you'll have x equals, and on the other side, you'll have a's, b's, and c's. You should not have y and z. You should have only a's, b's, and c's. So, as we did the last time, right, we saw that there were 2 x's and 2 y's and 2 z's, and we added both sides. And this is very similar to that. If you go back, you'll see 2x plus 2y plus 2z. You add this, you get a plus b plus c, and you take out 2 as a common factor, and 2 multiplied by this is equal to that. So therefore, x plus y plus z is a plus b plus c divided by 2, because 2 times that quantity is this, right? And then, as we saw earlier on, you need to find x, that's your unknown, right? So the unknown in this problem is x. So let's isolate x, but the other part, y plus z, we already know is hidden there. See, y plus z, and that is equal to b. So now you got x plus b equals this. You can solve for x by bringing x to one side and taking b to across the equal sign becomes minus b, and you simplify this to get a minus b plus c over 2. I went through this briskly. You can have a look at it in your own spare time and understand it. The principle is exactly the same as the one that we did earlier on. We move on to problem 7. Problem 7 states, let a and b be real numbers for which a over b plus b 4b over a equals 4. You got one equation, but 2 unknowns, a and b, one equation. Now, usually you need to have one unknown with one equation, or 2 equations with 2 unknowns. But here you got a single equation. But then you're not asked to find the unknowns. You're supposed to find just the ratio of the unknowns, a over b. So that will certainly help to solve the problem. Okay, so we don't know what a over b is. So let's give a name to that a over b because it occurs here. So we can say let x, let x be equal to a over b. So let's call this the unknown. Then what happens? When you substitute there, you get x plus 4b over a equals 4. But now b over a, what is b over a? If you see b over a, it's actually the reverse of this. It's 1 over x. 1 over x is equal to b over a. So we can replace this b over a by 4 times, this is 4 times b over a. So that is 4 times 1 over x, which is 4 over x, and that equals 4. And there we have it. You've got one equation with one unknown x, and the unknown is what we require to find. So let's try to solve this unknown. As we said earlier on, don't like fractions. The common denominator is x. You can multiply right throughout by x here to get rid of. But you must multiply on both sides. Be careful. So you multiply this by x and you multiply that by x. Now x times x is x squared. And here x times 4 over x is 4x over x, which is just 4. Now, what is this? Now, you don't have a linear equation, but you have x squared. If you bring all the x's to one side, but actually you leave the number on the other side as well. In this case here, because if you look at this carefully, you will see that x squared minus 4x plus 4, see, this is actually x squared minus 4x plus 2 squared. And you will notice that this is really x minus 2 all squared. See? Because minus 4x is twice the product of these two. Okay, so what you've got here is x minus 2 all squared equals 0 at the left-hand side. And the only number whose square is equal to 0 is 0. So x minus 2 is 0, therefore x equals 2. So there's only one solution for x, and that is x equals 2. And if you go back, because we said x equals a over b, answer the question, x is a over b, substitute, and that's the solution to this problem. There's only one value for a over b, namely there is quite an easy way to solve problems like this when you are asked to calculate a ratio. And the way to do it is to give a name, as we did, to that ratio, like a over b here, like we called it x. You can do that. But the next step is quite crucial. Let a over b equal to x. Then you say, then a equals bx. Now this is very useful because when you put a equal to bx, now you can replace a by bx wherever you see a. So this equation here becomes bx over b plus 4b, and a is bx, equals 4. So you don't have to think too much about it. See, x, I'm sorry, it's bx over b. Bx over b. So that is x. And here the b's cancel. 4 over x equals 4. So you get an equation, one equation with one unknown, and proceed as we did before. So this is quite much easier and a simple way of doing it. Replace the numerator by bx and substitute. See. All right, let's get on to the next problem, which is number 8. We will now move on to some problems concerning averages. Now let's quickly recall what average means. If you look at the first question here, we ask, what is the average of 4, 6, 10, and 28? I think all of you know, to find the average, what you do, the average of the 4 numbers, you add the numbers, as we have done here, and divide by the number of numbers, which is 4, right? And you'll get the answer, which is 12. So what is important here is the average of the 4 numbers is the sum of the 4 numbers divided by 4, right? So in general, if you had not necessarily 4 numbers, if you had n numbers, then the average of the n numbers is equal to the sum of all the numbers, the n numbers, divided by n. And you'll always divide by the number of numbers. And if you look at this division converts to a multiplication, because when you divide this by n, you're going to get that. So what does this mean? It means that the sum of the n numbers is equal to n times the average. So a very, very important formula, that the sum of n numbers is always equal to n times the average of those n numbers. So let's look at an example to illustrate what we have just said. A set of 12 numbers has average 18, but the smallest and the largest have average 28. What is the average of the others? Okay, now remember, the last thing that we said was the sum of a collection of numbers is equal to the number of numbers times the average. So we know the number of numbers is 12. We know the average. So therefore, we can work out the sum of the 12 numbers. It will be equal to the number of numbers, which is 12 times the average. Right? This is a very important formula. That is 12 times 18, that's 216. So just bear in mind that when you're adding 12 numbers, right? 12 numbers, the answer is 216. The sum of the smallest and the largest, they say here, it has the average 28. Now, there are only two numbers here. So the sum of the smallest and largest is 2 times their average, and the average is 28, so it's 56. All right, so suppose the first two are the smallest and the largest. So these two, they add up to 56. And the whole 12 numbers, the 10 here, right? They all add up to 216. So immediately you should know what the sum of the remaining 10 numbers is. There it is. The sum of the remaining 10 numbers is 216 minus 56, because 56 plus the remaining 10 numbers is 216. So the sum of the remaining 10 numbers, or the other 10 numbers, is 160. So the average of the others, which is the average of the 10 numbers, is, again, you go back to the formula. It's a sum of the 10 numbers divided by the number. Now you have 10 of them. So we have worked out that the sum is 160. And so it's 160 divided by 10. And the answer is 16. Let us now move to the next problem. And this is another problem on averages. The problem reads as follows. The average age of teachers at an institution is 35 years. So in some institution, you've got teachers and their average age is 35 years. And the average age of its professors, so the institution has got teachers and professors, their average age of the professors is 50 years. Now, if the average age of the teachers and the professors, in other words, all combined, is 40 years, what is the ratio of the number of teachers to the number of professors? Right, it looks like a difficult problem, but if you do it systematically, then you would get to the answer, right? So at the starting point, your question is, what is the ratio of the number of teachers to the number of professors? So we might as well give a name to the number of teachers, right? And we're calling it X, as you can see. And we give a name to the number of professors, and we'll call that Y. Okay. So the question says, what is the ratio of the number of teachers to the number of professors? So that is X over Y, because that is the ratio. So we need to calculate this X over Y using the information that is given. So let's have a look at what the information is. The average age of teachers is 35 years. Now, you know you've got X teachers. So the average age of X teachers is 35. So that allows us to say the average age of X teachers is 35. That allows us to calculate the sum of all the ages of the teachers. The sum of the ages of the X teachers will be 35, the average, times the number of teachers, which is X. Okay, so that gives you that statement. And similarly, the average age of the Y professors is 50. The sum of their ages will be 50Y. So you now know the sum of the ages of the teachers, and you know the sum of the ages of the professors in terms of X and Y. So in other words, the total, the ages of all the members of the staff, the teachers and the professors combined, will be 35X. Those are the ages, total number of years that the teachers have, and that is the total number of ages of the professors. So they will have, the total is 35x plus 50y. But there's another statement here which says the average age of the teachers and the professors together. Now you are looking at x plus y people, and their average is 40. So the average of 40 x plus y people is 40 years. So the sum of the ages of all the x plus y people will be 40 into x plus y. So you have that the sum of the ages is 40 into x plus y, but we also said the sum of the ages of everybody, but we also said the sum of ages of everybody is 35x plus 50y. So these two will have to be the same, right? And that is what I've got here in this little box. So you have an equation, right? And when you simplify this equation, 40x plus 40y on the right-hand side, bring the y's and everything to one side, right? As we have done, bring the x's to the other side, you'll get 10y, 50y minus 40y is 10y, 40x minus 35x is 5x, right? And then you cancel off, divide by 5 right throughout, and you get 2y equals x. And if 2y is equal to x, to get x over y, you divide on both sides by y. Then you divide this by y, and you get 2. And yeah, if you divide this by y, you get x over y. And that's exactly what we needed to calculate. So x over y is 2y over y. That is 2. So that's the answer to that problem. Problem 10 is also a problem on averages. Let's read it. Before his last maths test, Sunil's average was 33%. In his last test, he scored 40%, which increased his average to 34%. Right? So he had a 33%, he scored a little bit more, and his average is now gone to 34%. And the question is, if he wants to increase his average to 35%, what must he score in the next test? All right, so we don't know how many tests he had written to get an average of 33%. So suppose he has written n tests to get an average of 33%. In other words, before his last test, suppose he had written n tests. So suppose Sunil wrote n tests before the last one. Okay. So that means his average in n tests was 33. Now we know now, when you know that, then you can work out the sum of all the marks that he got, right, in those n tests. It will be equal to average times n. So the sum of all the marks before the last test is 33 times n, because he has written n tests. But now in his last test, he scored 40%. So now his total marks was 33n, and he scored 40% in the next test, the last test. Okay. Now this is the n plus 1 test. So therefore, his average, his total marks would be 33n plus 40. Right? But this increased his average to 34%, which means that in n plus 1 test, the last test, right, together with the previous n test, this n plus 1 test, his average was 34. So his average for n plus 1 test is 34. Therefore, the total in n plus 1 test is 34 into n plus 1. But this is exactly the same as 33n plus 40, because this gives you the cumulative sum for up to the last test. So these two are the same. So once you do the same, you got the equation, you can solve this equation, and you see that n is equal to 6. So in other words, he had written 6 tests before the last one. Okay, just have a look at how many. So if you put that 6 into this line here, it says that the sum of all the marks up to the 7th test, right? His 7th test, he scored 40%. The sum of all the marks up to the 7th test is 34 into n plus 1, which is 34 times 7. And that gives you 34 times 7, that gives you 238. So now we know how many marks he scored in all the 7 tests before he wrote, yeah. Now, he's going to write the next test, and he wants the average to be 35. So in other words, he wants the total of 8 tests, right? He wants the total of 8 tests to be 35 times 8, because he wants the average of 8 tests to be 35. So therefore, the total of 8 tests will be 280, 35 times 8. But we already know the total of the 7 tests, which is 238. So therefore, that allows you to say what the 8th test score is. The average of the 7 tests is, the total of 7 tests is 238. Total of 8 tests is 280. So the 8th test, his score would have been 280 minus 38, which gives you 42%. So that is the score he has to make in the 8th test or the next test to increase his average to 35%, namely 42%. All right, we move on from averages to another type of a question. Sophie runs the Comrades Marathon every second year. In other words, she doesn't run it every year, but she runs it after every 2 years. When she has run a 7th Comrade, the sum of all the years in which she has run is 14,098. In which year did she run her first Comrades? So the question is now to find the year in which she ran the first Comrades. Okay, so we don't know what that is. So let X be the year. We'll say that year in which she ran the first Comrades. All right. Now, when you add all the years in which she has run, so if you start from the year X, right, and then she runs it every 2 years. So the next year will be X plus 2. The next one will be X plus 4. So the year X plus 8, X plus 10. 1, 2, 3, 4, 5, 6. Okay, X plus 12. She runs 7 Comrades altogether. Right? 1, 2, 3, 4, 5, 6, 7. And if you sum all the years in which she has run, right? So in other words, when you add all these numbers, you're going to get 14,098. So if you add all these numbers, but you can add all these numbers. You've got 7 X's, and you're adding all these numbers, 42, when you add these numbers. So this, when you add these 7 numbers, you get 7x plus 42, and that is equal to 14,098. So you can solve for x now. I bring all the numbers to one side, 1498 minus 42, get 14,056. So x is equal to 2008. So that is the year in which she ran her first Comrades. So she ran first in 2008. We turn our attention now to inequalities. Now, inequalities, as opposed to equalities, where you have an equal sign, is where you have a less than sign or a greater than sign, or the sign here, which means less than or equal to. Sorry. And this one here is greater than or equal to. could be equal or it could be greater. But this one here is strictly less, cannot be equal. Okay, so when you have an inequality, you got some object less than something else, some number. You can add the same number to both sides. I can say a plus 1 is less than b plus 1. You can even subtract. A minus 5 is less than b minus 5. You're allowed to do that. You can multiply on both sides, but you can only multiply by a positive number. You can say, for instance, 5a is less than 5b. 100a is less than 100b, right? But when you multiply by a negative, you must be careful. You can multiply by a negative, but the sign changes. Like, for instance, if you multiply this by negative 5, this becomes negative 5a, then you change the sign and becomes negative 5b. So when you do multiply, you can multiply by a negative, but the sign changes. All right, so much so for inequalities. Now, I just want to say something about counting. If you got a whole list of consecutive numbers, m plus 1, m plus 2, and so on, or like, for instance, 53, 54, 55, up to 217, and you want to know how many numbers are in this list of consecutive numbers, there's a very simple formula for it. You might be tempted to say that it's the last number, 217 minus 53, but that will be wrong, because the answer is really 217 minus 53 plus 1. You must add 1 to it. See? So this is 217 minus 53 plus 1, right, which gives you 165. So when you got consecutive numbers, you can add, you can find out how many numbers there are in that list. Okay. Through this formula here, you take the last number and subtract the smallest, but remember to add 1 to it. So let's see an application of what I just said. Right? So we have the problem here, which says, well, how many integer values? Integers are the counting numbers, 1, 2, 3, 4, and so on, but also the negatives. The negative numbers like negative 1, negative 2, negative 3, and also 0. So the integer numbers are all the whole numbers, right? Starting from the negative, 0, and the positive numbers, no fractions. Right? For how many integer values of n will the value of the expression 4n minus 5 be greater than 1 and less than 200? All right, so you want 4n minus 5, 4n minus 5 to be greater than 1. That's a sign, greater than 1. Right? Now you can solve for n here. How do you do that? Just as we did before. Right? You can take 1 to the other side. And n is equal to, n is greater than 6 over 4. You can multiply by a quarter. Well, that's positive. So we're multiplying by a quarter on both sides, and you get 6 quarters here. So n is greater than 3 over 2, but remember, n is an integer. So which numbers are greater than 1.5? So it'll be 2, 3, 4, 5. These are the, I'm sorry, and greater than that, then n is equal to, n will be equal to one of these numbers. So the numbers which are greater than 1.5 are 2, 3, 4, 5, and so on. But you also have the other statement here that is less than 200. So you also have and, right? And 4n minus 5 is less than 200. And you do the same thing here, and eventually you get that n is less than 51.25, which means that n is 51, 50, 49, and so on. So n is, so if you combine these two statements, so n starts from 2, 3, 4, 5, and goes all the way up to 51. Right? It cannot exceed 51 because it's less than 51 and a quarter, so it can't be 52. So now you want to know how many integer values are there. So you want to know how many numbers are in this list, right? We just answered the question. There are, so how many solutions altogether? It's 51 minus 2 plus 1. They ask you how many integer values. So there are 50, because this is a list now, consecutive numbers, and we just said, give you a formula for that. Okay, so that takes care of problem number 12. We can go to problem number 13. Number 13 says, for how many positive integers n less than 50 is the product this positive? So you want the positive integers less than 50. So n could be any one of these, 1, 2, 3, 4, going all the way up to 50, but it must be less than 50. So you go up to 49. So you want to know for how many of these is this product positive? So let's try these values. N equals 1. We'll do it mentally. N equals 1, then this is 1 minus 8, which is negative 7. Here you got 1 minus 38, which is negative 37. When you multiply negative 7 and negative 37, you get a positive quantity. And so the answer is correct. So here you say there's a tick here. And if you try n equals 2, again you get positive. The problem arises when you come to 8. Because when you come to 8, this is 0. So let's see what happens at 7. 7 minus 8 is negative. 7 minus 38 is negative also. So those 7 are accepted, but not 8, because that is 0. And likewise, you come to 38, and that's not accepted. And in fact, you try all these numbers here, you get all negatives here. But from 38 onwards, 39, when you put n equals 39, this is 39 minus 8, that's positive. 39 minus 38 is also positive. So 39 and 40 and all these are positive, going up to 49. Right? So the answer is, how many numbers are there altogether? Well, you've got 7 in the front. You don't need a formula for that. 1, 2, 3, 4, 5, 6, 7 plus. But here you need a formula because this list here starts from 39 and finishes at 49. So it's 49 minus 39 plus 1. Remember, okay, you're not allowed to put 38 because that gives you 0. 39. So if you work this out, you get 7 plus, and this is 10 plus 11. The answer is 18. All right, so that's the answer to that problem. You simply substitute and see where the answer is positive. And wherever it's positive, you put a tick there and count the total number of ticks. So that is the process. The next problem says that if a plus b is equal to 6, so you know the sum of the two numbers is 6, and the product AB is 4, you are asked to calculate the sum of the fourth powers. Now that looks very complicated because you don't know what A is and what B is. Sometimes you might want to try to solve for A and B, and it can become very, very tricky. But there's a very clever and beautiful way of doing this, right? And that is noticing that if you square this, you'll have A squared plus B squared. And if you square A squared plus B squared, you're going to get A to the fourth plus B to the fourth. So we're just going to exploit that idea and be quite careful in the way we handle it. So I'll start with A plus B, and I'll write the formula for A plus B all squared. And if you remember right in the beginning, I said A squared plus A plus B all squared looks like A squared plus B squared, but you must add twice AB to this. Right. Now we know what A plus B is. It's given, A plus B, there it is given as 6. So we'll substitute for A plus B on the left-hand side. And on the right-hand side, you got A squared plus B squared. You don't know what that is, but plus 2AB you know. So I can put a 4 there. So now you've got, the only thing you don't know is A squared plus B squared. Let's make that the subject of the formula. A squared plus B squared. That is equal to 36. And you take this to the other side, and you get minus 8. And the answer is 28. And so A squared plus B squared, to summarize, is 28. Now we can get, in the same way, we can get to A to the fourth plus B to the fourth, because you stick this and you square it, right? We know what this is already 28. So when you square it, you get the same thing, and you can just follow these calculations, and this part here, A to the fourth plus B to the fourth, you can make it the subject of the formula, right? It's equal to 28 squared. That, and you take that to the other side, 28 squared is 784. AB is 4. So you got 4 squared is 16, times 2 is 32. So it's 784 minus 32. And there you have it. You have that A to the fourth plus B to the fourth is 752. So that's, I think we will stop here. We have tackled 14 problems, and I don't think I have time to do any more problems. But there are a number of other exercises which we will give you. Your tutor will give you those exercises, and you can try them out. Right? As you can see, some of them can be quite challenging, but apply your minds and try to think of ways of trying to solve the problem using symbols and so on, as I have shown you. And if you don't know how to solve it, don't feel too bad if you don't know how to solve them. But what is important is that you must look at the solutions and learn this style, learn the strategy which is used to solve the problem, because what this whole program is all about is to teach you to develop problem-solving strategies, so you can use those techniques in various situations to solve different kinds of problems. So try to do your best whenever you have got an assignment or whether you got new problems, tackle them. Mathematics is very beautiful, and you get a tremendous thrill once you solve a problem, especially challenging non-routine problems like the kind of problems that we are doing in this program. Thank you very much.